basically, this slide is very interesting in terms of commercial and the strategic impact. If you look at the numbers, so these, even simple, these three success or case histories added close to 8 to 9 million oil in place, plus that 32 BC of gas, proven gas in the area, and also highlighted the potential of stratigraphic trapment and the truncation play in the area. And other impact is, if you just look at these production plots, so these are the hydrocarbon and water, the well production plots. So this is the, if you get a look at the first production plot, so this is the area that this field has been declined. And this is the time that we were thinking about to relinquish the area or the lease. But thereafter a gap of 6 to 7 years, this is the, like you can say, the new life of the field. Same, this is the second field, and also this is the first, like you can say the performance, previous performance, and after that success, this is the like updated or new life of the field. And same story repeats over there. So I will just end it over here. So the key, like I would give the key message that we should, in our matured asset, we should relook into the fields, and because there are some reservoirs which are bypassed, because initially we only focus on the key zones. And this type of attributes, not quantitative, basically sometimes qualitative attributes also help us to basically give the qualitative idea about the sand presence or sand truncations, where we can use and integrate with the other well data to target these zones. So if now the other aspect is if we are successful able to target these zones, so that can help, basically that can aid or give the new life to the fields. Thank you. So please, if any comments or feedback, please let us know.
Any questions?
Okay. I came a little bit late, but I was looking at one of your sections when I entered into the hall, displaying the structural style of this part of the lower Indus Basin. There were a few structures like normal faults, and then some unconformity events, and then stratigraphic pinch-outs. And then there was I was looking at a regional anti-form. What is the relationship between these different structures? I mean, the regional anti-form, the normal faults,
yes,
and then the unconformity events.
Yes, sir. Basically, when the cross section you are referring, it's basically the cross section which is starting from the northwest, and the area where our field is located. This is the eastern part of or the shallower part of the basin. So there is like there is like you can say the unconformity at the top of lower Guru farm where the sand sequence absents and the upper part of Guru deposits. So that's also basically that's an unconformity, and that is also the reason that we are one of the truncation play which we're discussing. That is the result of that truncation, because when we are coming to the southeastern part, the basin is getting shallower, and even that the reservoir which we are talking about, that is located at, I think, yes, it's 2,500 feet depth in the subsurface.
It's actually a good work, actually, no doubt there is.
Sorry.
Okay. Whatever you shown is basically is based on the bypass sands, and which are actually thin to the resolution of the sizing so far, but whatever I found actually. But at the parallel, you have good sands which are already produced in your area. But how can you say that the facies you are plotted in the form of the color attributes, they are representing the bypass sands only, because it can be reflecting the other sands which maybe you have already proven in the form of commerciality. So how will you differentiate that attribute map is only reflecting your bypass?
No, basically the sand which was I referring to that was producing, that was more shallower, because that attribute is representing a specific interval of 100 or 150 feet. So that is basically we have bound that interval with the time. Like if you can say if we are marking or interpreting a reservoir, so it's capturing a 10 millisecond above and like 20 or 15, 20 millisecond below of that section, and it's showing a composite response. Yes. Yeah, bypass in the sense that when the initial, if we talk about specific that field, that initially that the three wells which were drilled that have the tighter reservoir facies. So understanding was that okay, that in the area there is no reservoir quality. But in the same area, when we like we some if we drilled a well and it encountered the good quality reservoir without any basically we have like no if we have no work over there. So it gave us idea that okay, the good quality is present in the surrounding that need to be basically that need to be searched out.
Assalamu alaikum. Mubassam, first of all, I would like to ask the depth of these reservoirs which you have worked, because in seismic we have a challenge of resolution and the tuning issues in RMS amplitudes. Sometimes they show composite responses. Other is, have you validated these the work? Any depositional study based on well-logged data, core data, the depositional trends, the deposition patterns you have identified through any sedimentological study or?
Yes, that is first of all the reservoir depth. If we talk about the first field, that is also mentioned that it is like 3,000 feet or 2,500 feet, and the second field that depth is close to 8,500 and 9,000 feet. And yes, that when I said that it is integrated with the well data, so we have like significant well control in the area. So that means we tied it with the well data, and after that, basically now this is the post-success work, and now it's basically supplemented by the drilling of the new results as well.